Here's a video solution of the third problem on the online problems that are for the integration review, chapter 5 review. I've already drawn the picture of the graph of the line that's described here, but the question is to set up area, an area function, which means that we're going to have a function, a region that's described in terms of a variable x, and then we have to find the area of that region. The region is supposed to be the region below this line, above the x-axis, and between 2 and x. So we know it tells us x is greater than or equal to 2. So we know that x is some number to the right of 2. It doesn't matter what it is. We just draw it anywhere. And then we try to draw the region that they're talking about. Maybe we'll shade it in a different color just to be cool, like that. So we're trying to find the area of this green region, and that area will depend on the value of x. If x is bigger, the region will be larger, and so on. So the way we do that is we think, okay, well, that's a trapezoid, and so from geometry we know how to find the area of a trapezoid. If you were in a pinch and didn't remember the formula for the area of a trapezoid, you can just recognize that a trapezoid is just a triangle sitting on top of a rectangle. Sort of think of it that way. And if you can remember those two formulas, then you're also in good shape. But I do happen to know the area of a trapezoid, and it's an online problem, so hopefully you would just Google it. But to get the area, I need to know the dimensions, and the dimensions are going to come from the coordinates of these points. So over here on the left, this point we know has first coordinate 2. The second coordinate can be found because we know the equation of the blue line. The equation tells us, the formula for the function tells us how to find y coordinates. So if the first coordinate is 2, then plugging 2 into the formula is going to give me 5 times 2, which is 13. That will be the y coordinate at that point. So similarly, if all I know about the first coordinate is that it's called x, then the y coordinate is going to come from plugging that into the formula, which means the second coordinate is going to be 5x plus 3. So in every case, the points on the graph of a function, the second coordinate comes from plugging the first coordinate into the formula. So these are my coordinates, which means that I now know the height over here is 13. I know the height over here is 5x plus 3. So I know how long these little sticks are. I know the distance across here is x minus 2. To find the distance between 2 points on the axis, we just subtract, take the bigger one and subtract the smaller one, and that's going to be how far apart they are. So I now have a trapezoid with all the parts labeled. The formula for the area of a trapezoid is just the base times the average height. That's how I like to remember it, base times average height. So the average height we can find because we know the two heights. The two heights are 13 and 5x plus 3. So the average of 13 and 5x plus 3 is just 1/2 times 13 plus 5x plus 3, which is, I'll put the 1/2 out here, and 13 plus 3 is 16 plus 5x. So that's the correct formula for the area of the trapezoid. That would be the first answer. I honestly don't know if MyLabs Plus cares if that's multiplied out or not, but just in case it does, and also because I know the next question it's going to ask me, I'll go ahead and do it. If I do FOIL on the stuff inside, I'll have 5x squared plus 16x minus 10x, so plus 6x, and then minus 32, which I could also write 5/2 x squared plus 3x minus 16. So that answer for sure will make higher logic happy. I'll write up here my trapezoid formula. Base times 1/2 the left height plus the right height. Just call it like that. That's what I was doing. So the formula, I think of it as base times average height, but you can find it by doing base times the half of the sum of the two, the left half and the right half. Anyway, so that's the answer to the first problem. The second problem is asking for a prime of x. I think there's a problem in between where they ask you which they ask about the graph of that, but it's multiple choice. The derivative, it's nice that we have this multiplied out because the derivative now is just simple derivative of what I have in the box. So the derivative of 5/2 x squared is 5x. The derivative of 3x is 3. And this formula should look familiar because this is the same as the original function that we started with. And that is the essence of the fundamental theorem of calculus, what we normally call the first version of the fundamental theorem of calculus, which is that the derivative of this integral is just the same as the function. So there's a version of the fundamental theorem of calculus that you might have seen that looks something like that. This question doesn't assume that you know that. This question is asking you to work it out using geometry as if you have not seen the fundamental theorem of calculus yet. This is a problem from chapter 5 that is working its way up to showing you why the fundamental theorem of calculus is true. But that's how you do it.